Barry. What I'm going to do is just take you through a brief introduction to who we are, talk about the project just to let everyone know what it is, talk a very little bit about our brief BIM history just to set the scene for what we did and how we did it, maybe talk about how we went to approach the project, and maybe the real bones of what I'm trying to present is the lessons we learned. So I'm not going to sit up here or stand up here and tell you everything went swimmingly and we got this all right at the very start and we got it the way we wanted it. We definitely learned lessons throughout this project, and we're continually learning lessons every day, and we're trying to improve ourselves and our processes. And hopefully I'll share some of what we learned on this, and hopefully maybe someone can tell me how I can be better at it even for the next one, or how we can be better at it for the next one. A quick conclusion, and we'll take any questions. So the company that were appointed to this project were Pivotal International, and it's actually a multidisciplinary company that we deliver multidisciplinary services into the Saudi Arabia market. It's actually made up of 4 Irish companies, fewer Harrington partners, Garland, who I work for, Noel Lawler Consulting Engineers, and Karen and Walsh. So fewer Harringtons were the architects in the team, we were the civil and structural engineers, Noel Lawler's the MEP engineers, and Karen Walsh our QS. We were a civil and structural engineering firm, been around for 80 years. Our primary service would be civil and structural engineering. We also offer safety management, assigned certifier services, and an economic development service. And actually, we started this project delivering an economic development service. So what we were advising, or what we advised a client on originally, who was EMER EC, what we advised them on was the market need and the feasibility of the project in the first place. So during that service, during that operation, we gained their trust, which then moved on to an appointment for the master plan, followed by an appointment for the detailed design. There's the most photogenic photos of our practice that I can fit into one slide, and there's loads more on our website if you want to have a look. So the project that I'm here to talk about is the bonded zone of the King Abdullah Economic City. So like a typical Saudi project, they've literally had an ambition and a dream to create a city from nothing. So where there was nothing, they want to create a city. And part of that city is the King Abdullah port, and part of the presence of the port gave them an opportunity for a bonded zone. So what a bonded zone is really like a special economic zone, something that maybe has come out of the Shannon free zone model, which is actually world renowned, and a lot of who our experts were involved in originally, was to create a zone in the area that was different for tax reasons, that products could come into the port, be placed in this bonded zone, be touched up, remarketed, or just sit there and come back out again without any of the economic issues with bringing and importing into a country. So that was really the purposes of the project, of what the bonded zone is to be. So King Abdullah Economic City is actually bigger than Cork, and the industrial valley where the bonded zone is based is actually bigger than Limerick, and the bonded export zone is actually bigger than Monaco. So it's 3.2 kilometres squared, about 320 to 360 hectares. Not often I get one over CISC, but it's actually probably twice the size of Centre Parks, but don't quote me on that one. So that's the bonded zone in the corner. The bonded zone is here, which consisted of a wadi through the middle of it, which is actually probably the size of the River Shannon, and 2 zones either side of that, which was split up into phases for the project delivery. So a couple of visuals of the project. So part of the project was really going to be a concrete slab, and I'll give you some stats on that later on, which pretty much people are going to bring containers, TUEs, so 20-foot equivalent containers, park them in an area, and they'll probably go back out again in a future time. And the other areas, other areas of the site were dedicated to possible building structures or plots for someone to maybe buy a plot or use a plot for their own purpose, put a building on it if they need. So on this visualization, you can see containers where they're placed, and then maybe where the plots are behind them. So again, just some of the stats. There's 6 million meters cubed of fill to go on the site. There's 20 kilometres of different types of roadways, and the 32-metre wide roadway is actually probably the equivalent of a highway. 13 kilometres of water main, 10 kilometres of foul sewer, 20 kilometres of surface water swales, which are kind of open surface water channels, and closed surface water sewers. There's 500,000 metres squared of concrete slab in that container area, and it consisted of 3 major roundabouts serving those main highways. Our BIM journey has, I suppose, started in 2005, and we probably started with Civil 3D and BIM for infrastructure, and trying to use Civil 3D better than we are currently using flat 2D AutoCAD. Excuse me, I'll get this right eventually. In 2011, we started introducing BIM, Revit Structure being the tool to our structural projects. And what we've actually found is that over time, or during that time, our structural projects and our structural knowledge far exceeded what we were doing in terms of our civil work and our civil projects, our infrastructure projects. We completed our first close to level 2 BIM project around 2013, 14 and 15 in St. James's Hospital. And since then, we've been producing models every day throughout the company. But our civils had kind of fallen behind. Even though we'd started with the civils, we weren't in the same place with our infrastructure work or our civil work. And we started the BRZ design, schematic design in 2014, and we started entering the detail design in 17 and 18. And we knew we weren't going to deliver the project unless we were better at delivering civil projects using the tools that were available in the market. So that kind of led to our project approach. And the other thing we knew was that we were able to deliver, as a company, very large infrastructure projects. Since the 60s, we've been involved in Shannon Town since its inception. It's 500 hectares and has 50 kilometres of road. Raheen Industrial Estate is similar. Again, a greenfield site, 180 hectares, again, roads and infrastructures. We did that pre-BIM without BIM tools. It probably took us longer than it might do now, but we were able to do it without BIM. But we also knew that if we didn't upskill, if we didn't change our methodology, work better, work more efficient, we weren't going to deliver what A, the client wanted in terms of quality, and B, in terms of what the client wanted for a program. So we knew we had to change. We knew we needed to get better. We just didn't know what it is we needed to learn, and we started the project. And as a result, we started to learn a lot of lessons. And I think we have a similar story in terms of our structure, in that we knew we needed to do it. We knew we needed to be better with the structure back in 2011, 12, 13. But we also knew we needed to learn. And what we started to learn on this project was about data management, about how we needed to be lean in our inputs, how we needed to be more efficient at deliverable production, and the old rule, keep it simple, stupid, how our programs were interacting with each other and how we were interacting with them, and how we could use these tools for clash avoidance. And I think, for me, the lads' presentation on Centre Parks, the keynotes this morning, the kind of same words are coming up: data management, basic, simple, lean. And I think that's really the message I kind of have to deliver for how we wanted to try and approach the project. So kind of up to this project, our civil projects were quite small. We were able to manage them with one Autocad Civil 3D file. They didn't cause us much problems. We maybe had an XREF of a background in the program or in our Autocad. When we tried to apply that principle to a 320 hectare site, it just fell flat in its face. We had these huge Autocad files. They were taking hours, minutes, days to load, to save, to auto-save. We were just having huge problems dealing with the scale and size of the project, which is multiples of what we'd ever tried to do with the BIM tools that we had been using before. So what we encouraged and what we did as a group and a team, and what management encouraged, was for us to find a better way to do something. If we were struggling with something, stop, take a break, do some research, check it out. Someone's already solved this problem. Someone's already done a 500 hectare problem, a 600 hectare site. Someone's already looked at this and solved this problem. We're not the first to come to this problem. What was their solution? What did they do? And how could we apply it to our project? And I think that's one of the approaches we kept going throughout the project. Identify a problem, identify where we could be better, identify how we could make ourselves more lean, and see what it is the solution was going to be. And one of the first things we came across was an AutoCAD Civil 3D 2010 publication on best practices, which really opened our eyes to what way we should be doing it, what the best practice is, what Autodesk and those who wrote the paper thought that this is the way it should be. And we said, right, that's best practice. How do we make that work for our project? And we started, instead of having one individual AutoCAD file with all this material and information, we started to break up our projects and our data files and our AutoCAD files into simple drawings. So we had a drawing for the surface water pipelines, we had a drawing for the file pipeline, we had a drawing for the water main, we had a drawing for the road alignments, we had a drawing so we had all these different drawings at a base level, and we started to put these together at an upper level and link them all together so that there was one file that was small that was pulling off all the other ones. And the main way we did that is by using data shortcuts. And finally, at the top level, we really are only left with a drawing file containing our title block and maybe some notes that has linking all the others and is showing all the work and all the detail that's gone into the other files around it. So one of the quick wins we really did have in the project was trying to structure our data. We started to get a bit lost with all these multiple files, and as a team, some people started to break them up differently than others, and people couldn't work on what other people had done. So we started to figure out a map for how the things were going to be linked, and started to map our project in terms of what files are where do they go, and once we had that sorted, we had a much better understanding of what everyone else was doing, and we had a standard way to approach our data management. And again, we just started looking at the way that the files are actually stored on our server, so everyone knew where they were. And again, something we had in place before the project started as a pivotal group was a file naming structure. Not quite to BS 1192 standards or PAS 1192 standards, but it was a structure we had all agreed on and does work and did work for the project. We sorted out our data management project problem, and things were definitely working and were more efficient, but we still had problems opening, closing files, and particularly when we tried to meet a client demand, which I'll come to later on. When we started to look at the problem, and again, instead of dealing with the errors over and over again, coming up with the errors, we said, right, stop. Take 5 minutes, take 10 minutes, take a day. What's the error? What's the problem? How can we get rid of it? How can we take a day to fix a problem that's going to save us weeks throughout the rest of the program that we have for design? So what we actually discovered was that the background that we had been provided by the client, or they had provided to us, or had been worked on by other team members in Pivotal, had just become bloated. It had loads of crap in it. It had lots of linkages in it. It had just bad stuff going on in it, and it wasn't lean. There was lines over lines over line. It just wasn't a clean background. So what we did is we spent a couple of days cleaning up the XRF background, which made a huge difference to our file opening, file closing, and the way that we started to send the drawing around. So for me, it sounds very simple. In hindsight, a very clean background, very simple, basic background, which was all we wanted to show as an overlay on our drawings, actually helped us to deliver a much faster product and much faster design at the end. Deliverable production. So we had a very educated client, which is one of the things we identified in our project approach, that we had someone we could work with, that they've been delivering a project or an entire city. They know how others have been doing it. They know how they receive data. They know what works. They've already learned lessons, and they were willing to share those lessons with us. And we identified that. But one of the things we really struggled with was the way they wanted a deliverable. So we spent a lot of time figuring out how we could be more lean, how we could use all these shortcuts, how we could use all these XREFs, and how we could be faster and how things would be better. But what they wanted at the end of the day was, for every single drawing number, they wanted a single PDF, a single drawing file. But the drawing file wasn't allowed to contain any shortcuts, wasn't allowed to contain any XREFs. There was no zip files allowed, and they basically wanted to open up that Autocad file with it being anywhere on their server, and it opened for them without any issues. So we immediately had problems with all the Civil 3D data that we had. So basically what we had to do was basically dumb our drawing down, use the dreaded word of explode, and make the drawing file as dumb as we possibly could. We introduced them to the Civil 3D object enabler, but that didn't change their mind. They still wanted this drawing that worked when they opened it in AutoCAD. That actually started when the number of drawings we had to produce on a weekly basis ramped up to over 100 or 150 or 200 drawings a week. It actually was taking us 1.5 person weeks to deliver the deliverable every week, which is like 62.5 hours or something like that. And we just said, again, there has to be a better way. Someone else has solved this problem. This isn't unique. How do we solve this problem? And we started to come across, I think we started with a free Lisp that we had found from JTB World. And they are a software provider, a software company that basically script. I think they have a construction background or an AutoCAD background. They've produced and have available a lot of small little programs that solve a lot of problems. I suppose we were used to doing the structural project and having Revit available to us, that all our sheets were in a Revit file. We were used to producing deliverables on demand out of Revit, and we're saying, why can't we do the same thing with Civil 3D? And with a bit of research and a bit of work with JTB, we actually developed a little script that was replicating what we were doing manually. So we had about 10 steps to prepare a drawing then for the client. What we're able to do was automate this process with their script, with their program, and a script we co-wrote with them to say, we hit a button, the really intelligent Civil 3D file we have will eventually turn into 2 PDFs and a DWG file that we can then issue the client straight away. So it sounds easy, it sounds good. It was still using a huge amount of computer power. So although we didn't have to hit buttons and there wasn't time taken between the buttons, the computer was still churning away to try and deliver all this stuff and to prepare all this stuff, because we were trying to move all this huge data and link all this huge data together. It was still using a huge amount of computer power. So ideally, we'd run this on a Thursday night, and we'd come in on Friday morning, and we'd have 100 PDFs and 100 DWGs waiting for us to upload onto the CTE. But sometimes we'd hit an error, and because someone had opened a drawing, the Autocad drawing in 2019, but it was prepared or run on a computer with 2018, we'd get an error, and second drawing in, the error would stop the 100 drawings be prepared. So we're still working through the script to see how much code we can write in that when it comes across the errors, instead of having someone available to hit the return button to get rid of the error, that it's all automatic, the errors that we're seeing can be ruled out. But we're also trying to see what it is causing the errors in the first place and what systems or processes we need to put in place to make the errors go away in the first place. So there's always a better way, usually. Keep it simple, stupid. So one of the big things we have to do with this project was to deliver cut and fill analysis. And again, with the size and scale of the project, we were getting numbers out of Civil 3D of millions. And we really didn't grasp if the millions was a right figure or a wrong figure. Were we wrong by a million or were we wrong by a decimal place? We just didn't have a feel for it. And even when we did simple checks of cross sections, we were struggling to get similar answers regardless of how we did it. But eventually what we discovered was, we were having, and maybe it can come through on the screen, we were having these issues where the contours were going mad for us. We knew there was something wrong with the file. The contours were behaving wrong. When we visualized it, something wasn't looking right. What we found out was that actually we had too much detailed information in our cut and fill analysis file. There was lots and lots of data, there was some incorrect data, and the contours were jumping to points that we didn't even know were there and we didn't even want it to be there. So what we ended up doing was trying to go back to basics, like has been said a couple of times already today, figure out what it is we were trying to show, figure out the key targeted points in our model, in our surfaces we wanted to achieve, and keep it very simple. So you can see the huge difference maybe in between the contours on the left and the contours on the right. Probably didn't make a huge amount of difference in terms of the overall quantities when we were finished, but we were able to reassure our client that he was able to look at the contours, we were able to look at the contours and know that the figure was right, the figure was what we needed to. And on the very right here is what the cut and fill analysis looked like, mostly lots of fill. We did a lot of work on program interoperability. So we'd learned our lessons in structures and we wanted to apply them to civils. And again, just like the structural side of our business, we were working with other disciplines and other practices and clash avoidance, and we started to apply that in our Civil 3D work and this project to make sure water mains, foul sewer, and surface water were all clash-free with each other. So the key things I think we learned is that, and again, it's been said a lot of times already this morning, data, but the data has to be lean and it has to be structured and it has to be something people can use. There's usually always a better way to do something, and someone's already found it, so go find it and see if you can apply it on your project. And I think we were lucky in that we had an educated client. They were driving us, we were driving them, and I think the two of us together made sure that we were able to deliver quality deliverables to them. And again, keep it simple. And just because you can do something, just because the tools allow you to do it, doesn't mean that you should. I think that's a really important thing that we learned on this. And the other thing that I think we always keep remembering is that we delivered these type of projects without BIM tools. Probably it took us longer, probably it took more resources, and probably there wasn't the same amount of change that went on in a project then as there is now. But don't abandon pre-BIM techniques. The tools and tricks and rules of thumb that we used prior to BIM should still be used as a check to make sure the quality of what we're delivering is right when you're delivering a BIM project as well. So, thank you.